Welcome to the 8th grade. Today in this first video of the semester we'll be looking at one-step addition subtraction equations. This is something that you've done a lot in your career already. So let's start with just three numbers. And those three numbers that I've chosen, we can pick any three numbers that are easy to work with. So I've chosen to work with 2, 5, and 7, and our goal is to write three addition and subtraction equations just using these three numbers. I'll do the first one, I'll do the easy one, right? And it's kind of obvious that 2 plus 5 equals 7, so we're looking for things like that. But now you're going to have to write the subtraction equation. So what I'd like you to do is pause this video as you write those two equations, and we'll be right back. To be fair, I could have written this first equation as 7 equals 2 plus 5, or any variations of those. I'm thinking that perhaps the first subtraction equation that you did looks like this. Maybe, maybe not. But you could say that 2 equals 7 subtract 5. And maybe if you had been writing your equations like this, you may have written 7 minus 5 equals 2. Now look, these equations are written backwards from each other, but it doesn't make any difference how you write those. Now if we had solved this first equation here for 5, we might have written 5 equals 7 subtract 2. Or if you're working over on this side, you may have written 7 minus 2 equals 5. Now there's a pattern. There's a pattern that happens whenever you write the equations like this. And what I'd like you to do right now is pause the video and come back in a minute or so and identify what pattern you see whenever numbers move from one side of the equal sign to the other side. Okay, welcome back. If you observed that whenever numbers move across the equal sign, that they change sign, give yourself a pat on the back. If you didn't see that pattern, look at it now. Maybe even pause the video and make sure that you see that that's what's happening. So if you feel confident with that, I'm going to give you one to do by yourselves. You can work with a partner if you like. So I'm going to give you the numbers 4, 9, and 13. And what I need you to do at this point is to write three addition subtraction equations just like we had before, but in this case relating 4, 9, and 13. Go ahead and pause the video for a moment while you work on those equations. Welcome back. I'm thinking that perhaps you wrote these equations, and these aren't the only equations that can be written, but as we follow this pattern that we've had, these are probably the ones that you wrote. So starting off, we can add 4 plus 9 to get 13. We could have written it like this. 13 equals 4 plus 9, or we could have written 9 plus 4 It doesn't make any difference what order you add in, so either one of those is good. Let's say that we lock down this 4 and we were solving this equation for that. We would have 4 equals 13 subtract 9, and on this side over here we would have written 13 subtract 9 equals 4. One more equation. Let's say that this time we wanted to solve this equation for the 9, get 9 all by itself. We sometimes say we want to isolate a number or isolate a letter. So we're going to isolate 9, and we would write 13 subtract 4. And on the other side, over here, we would write 13 subtract 4 equals 9. Now, it doesn't make any difference what order we write these equations in. These are exactly the same relationships. In fact, all of these equations, right, are equivalent relationships, and they're all true statements. That's exactly what we're looking for. So if you did this and you feel confident with it, you're finished with this video. If you still need a little practice with this, you may want to go back and view the video, make sure that you understand it before we go any further. From here, we're going to start working with letters and numbers, and at some point soon after that we'll work with nothing but letters, but still just doing addition and subtraction. I look forward to seeing you in the next video, but for now, that's all, folks.